All right, guys, we're going to be looking at lesson 15. We went over yesterday what it means when you have two congruent triangles, and so now we're going to go over the congruence criteria, which is basically the criteria you can use to prove that triangles are congruent. So to start off, look at this right here. The main point of this lesson is to prove that two triangles are congruent. For example, these right here. This is an example we had from yesterday where angle C matches angle F, angle B matches angle E, angle A matches angle D. So then side CB would match side FE. So basically what you do is you know that two triangles are congruent if they have 6 pairs of congruent corresponding parts. Congruent meaning equal size, corresponding meaning at the same location within the triangle. So when I say 6 congruent corresponding parts, what that would consist of, that would be 3 congruent corresponding angles and 3 congruent corresponding sides. So like right here, A, B, and C correspond to F, E, and D, and they're all congruent. And then you have the long side on bottom, the medium side facing inward, short side on the outside, short side on the outside. You'll see they have 6 congruent corresponding parts, 3 angles, 3 sides that are all congruent. Now here's the thing, here's what we need to figure out. So I think we have a typo here. So if you can prove that two triangles have 3 pairs of congruent angles and 3 pairs of congruent sides, 6 total congruent parts, you have proved that they are congruent. What I want you guys to think about is if it's possible to prove that triangles are congruent with less than 6 congruent parts. So obviously you match all 3 angles, all 3 sides are identical on this triangle to all 3 angles, all 3 sides on the next triangle. The 2 triangles are congruent. But can you shortcut it and use less than 6 parts? Can you use maybe 2 sides, 2 angles? Can you use 1 angle? Can you use 1 side? Let's go through and think about it. And so as we do this, I'm going to have you pause, think about it, and draw it. And then I'm going to go through it and draw the example. So first what we have, if you have 2 triangles and all you know is that they each have a tangent side, is that enough to decide that they are both congruent? So if all I know is that each triangle has a tangent side, is that enough to tell me they must be congruent? I want you to pause. I want you to think about it. I want you to see what you can come up with. And then I will give an example. Okay. So if all I know is that this triangle, let me make sure I'm in the view. Let's make this big so you can see it. If all I know if all I know is that this triangle has a tangent side, okay, and then this triangle has a tangent side. That's all we know about the triangles. They each have a tangent side. Are they congruent triangles for sure? Is there any way to make this the starting side of one triangle, this the starting side of the other? Do they have to be congruent? No, they don't. Watch this. Let's make this triangle look like that, and let's make this triangle look like that. And you can hardly see that. Let me grab a better pen. So do you see what I'm saying, though? How you look, this had a tangent side, this had a tangent side, right? They both had a tangent side. But do you have 2 congruent triangles? No, you certainly do not. All right, so let's go and look at the next question. If you have 2 triangles and all you know is that they each have a 20-degree angle, is that enough to decide that they're both congruent? So this isn't going to be perfect, but let's say if this is a 20-degree angle, and that's an angle on one triangle, and the other triangle has the same angle. They're both 20 degrees. Do they both have to be congruent if they both have the same angle? Yes or no? So I want you to think about this. Is it possible to keep these 2 angles and have 2 different triangles? Well, let's see. Let's have this go all the way down to there. Let's have this go like that. I can make a triangle like that. And then on this triangle, I could go like that. I mean, there we go. They both had a 20-degree angle, 20 degrees, but they're 2 completely different triangles. So having just one side or having just one angle in common That's not enough to prove that the triangles are congruent. So the next question. If you have two triangles and all you know is they each have a 10-meter side and a 20-meter side. So this won't be perfect. I'll get close though. If this side, we'll call this 10 meters. And then this other one has a side that's 20 meters. So we'd do like that. Can I draw another triangle with a 10-meter side and a 20-meter side? That's a different triangle. I can do whatever I want with the angles. So let's go like this, 10-meter side. And then I'm going to do another one about that same length, but I'm going to do it pointing that way. You see that? Look, 20 meter and 10 meter, 20 meter and 10 meter. So just because they have two of the exact same sides, does that mean they have to be congruent? No, it doesn't. Let's keep going. Make sure you're getting why having two sides in common is not enough to prove that they're congruent. Now we have two triangles, and all you know is that they each have a 30-degree and a 100-degree angle. Is that enough to decide that they're both congruent? So 30-degree angle, 100-degree angle. So they have two angles in common. So basically, a small angle like this would be about 30 degrees, and then 100 degrees is going to be a wide open angle. So that would be about 100 degrees. So they both need to have a 30-degree angle, and they both need to have a 100-degree angle. So we could do one like this. There's 100 degrees. And then let's go ahead and do 30 degrees. Okay, so here's a triangle that has 130. Is there a way to make another triangle that has a 100-degree angle and a 30-degree angle that's not exactly the same as that triangle? Well, let's see. Let's go ahead and do a 100-degree angle again. And then I'm going to go right now and do 30 degrees. Okay. Notice they're both very similar. They're the same. They look similar. They're like the same kind of triangle, but this one's way smaller. So if you have two angles in common, does that mean that they have to be the same? No, it does not. Lastly, let's look at number 5. If I have two triangles and all I know is that they each have a 20-degree angle and a 10-meter side, is that enough to decide that they are both congruent? So let's do a 20-degree angle and a 10-meter side. Okay, let's do another one with a 20-degree angle and a 10-meter side. But now I'm just going to go like this. So just because we have a 20-degree angle and a 10-meter side, does that mean they both have to be congruent? No, it doesn't. So you see, in order to make two triangles congruent, having one part that's the same on both is not good enough. Having two parts that's the same on both, that's not good enough either. So now let's get to having 3 parts. And so I'll tell you right now, the fewest number of parts you can use to determine congruence is 3. And even when you have 3 parts that are congruent, it does not necessarily work. I should change this to parts. It doesn't work with any 3 combination of parts. There's only certain combinations of sides and angles that will work. So in order to determine congruence, let's look at the figures below. Is it possible to prove a triangle is congruent with that combination of parts? So first, SAS, that stands for side, angle, and side, meaning you have a side, then the next angle, then the next side. If that's what 2 triangles have in common, do we know that they're congruent? So let's try this. So let's do side, angle, side. So if this side has to be, let's say 10 meters, and then this angle is going to be, we'll say 30, and this side has to be 20. Okay, let's do the same thing again. 10, 30, and then 20. Is there any way, I can't change what's there, I can do whatever else I want, but if they have a side and angle and the next side, angle, and the next side, if I turn these two figures into triangles, do they have to be the same triangle? Well, can I make this any longer? No, I can't because it's only supposed to be 20. Can I point it down at all? No, I can't because that angle is supposed to be 30. Can I make this shorter or longer? No, I can't. So literally all I'm left with doing is just connecting from here to here and connecting from here to here, and we end up with the same triangle, okay? So, and I want you to understand the SAS criteria, side, angle, side, means if all you have is a side, the angle next to it, and the side next to that, if I measure on one triangle that the side, angle, side are the same as the side, angle, side on another triangle, I don't need to measure the other angles or sides. This alone is enough to decide that they're congruent. So right here it says which answers prove that triangles are congruent. You'll go ahead and check SAS. Side, angle, side works. We just proved it. Okay. Let's try ASA. So angle, side, angle. All right, let's make this big again. So let's do an angle. So I'll go ahead and do a 90-degree angle. So 90-degree angle. Let's go right here. Let's do a 90-degree angle. And if, let's say if this one is about 20, and let's make this one 10. Two triangles, both with 90-degree angles. One of them is 20. The other has a 20-inch side. This has a 10-inch side. That has a 10-inch side. I can't change the lengths of either of these sizes. I can't change the length of those sizes, and I can't change the angle, so I can't take them and open or close them. So do we have any options? No, I mean, all you can do with this, let me make sure this is the same. Okay. All you can do with this is just complete it. And all you can do with this is complete it. And that's it. We're done. There's nothing else we can do. So ASA, having an angle, and then the next side. Oh, you know what? I'm so sorry. I gave you a terrible example. This was it. I just did side, angle, side again. So I'm sorry. We already proven that. Let me fix that. Let me do it right. Okay, we're doing angle, side, angle. Once again, sorry about that mistake. Let's do angle, side, angle. So let's do a 10-inch side. Go about the same. 10-inch side. Now let's do, if we want to go right here with a 90-degree angle. And right here, we're going to have a 90-degree angle. Okay, so 90-degree angle, 90-degree angle. And then let's make the angle right here. Let's make this a 30-degree angle. And let's make this a 30-degree angle. Okay, so I haven't completed the triangles yet. This is 90. This is 10. This is 30. This is 90. This is 10. This is 30. So it's an angle, then a side, and then another angle that are the same. Now, everything else can be different. This is a hard one. I think looking at that, you might think, yeah, I can make two different triangles out of that. Because I can make this long or short. I can make this long or short. But here's the thing. That has to be 30 degrees. So you can't take this and you can't point it in a different direction. It has to point that way. This has to be 90 degrees. So this has to point straight up. You can't change it. So watch what's going to happen. You can make this really long if you want. But your only option is to extend this until they meet. So even though we're not forced to make this side a certain length, that right there ends up being the only option. Look right here. Go ahead, make this as long as you want. It's not going to matter because this cannot change directions, so it's going to extend until it hits it. So if all I have in common is an angle and then a side and then an angle, is that enough to say that they're congruent? Yes, it is. So on this one, angle, side, angle, that works. So check, ASA is an option. Side, side, side. So if I have three sides in common, does it have to mean I have the same triangle? Let's see. So let's say, I'll make one side like this. We'll call that 10. I'll make another side like this. We'll call it 5. I'll make another side like this, and we'll call it 6. Those are the 3 sides. Is there a way to take those 3 sides, and if that's all I can use, do I have to make the exact same kind of triangle every single time? So if my first side is 10, and then my side right here is 10, and so watch, if I take 5, and then this one is 6, is there another way to go about doing that? Well, if I take 5 and point it that way, the problem is the other one is only 6. It can't reach it. So I'm trying to make a different triangle, but since this has to be 5, that has to be 6. I could try to take this and make that 5. But once again, this is supposed to be 6. I can't shorten it. So my only option is to do this again. Have this go 5, have this go 6, and we make the same triangle twice. So far we're 3 for 3. Side, side, side also works. So on this one, which one of these can prove congruence? Check side, side, side. Okay, now let's do side, side angle. So this would be a situation like this. I'm going to use, so I'll do one side will be 10, one side will be 5, and then somewhere in there, let's go ahead and do a 30-degree angle. Okay, so that's a 30-degree angle. So we're doing not side, angle side. So we're not doing a side and then an angle and then the side. Like we're not doing, let me show what I mean. This is a little different than right here. Right here we did side, angle, side, meaning do a side, have an angle in between, and then a side. We're doing side, side, angle, which means do a side, skip the angle that's in between them. So side, side, and then the angle after all that. Do you see the difference here between side, angle, side? It's a side, it's an angle, and it's a side. So you're doing the angle in between the two sides. When you're doing SSA, it means do a side. We don't know this angle. We have another side, but we do know the angle right there. So SSA, or when it's backward, it's ASS. So let's go ahead and do 10. I'll point the 5 that way. And then 30-degree angle would be like that, and it goes ahead, and it extends over to there. So the question is it possible to keep that angle the way it was, keep that length the way it was, and keep that length the way it was, and make some sort of a different triangle? Is that at all possible? Watch what we can do. Let's take 10. And remember, we can only have, and so if I take 5, and like if I go right here, the problem is that won't be 30. If I go like I did before, that's going to be the same triangle as before. But here's what you can do. Instead of doing it here, I'm going to make it go here. And it's possible to make the same kind of 30-degree angle, but it's going to be longer. So whenever you're doing side, side, angle, there is a different triangle you can make. Okay, so basically, because what happens, if I have a side, and this goes like that, right? Like, oh, you can't even see that. If I have a side, and this is going to go across, so this side could be any of those lengths. You could go right here and have an angle and take that same length and go right here. And you could have that, there's different ways to use the same length and reproduce the angle. So for this one, it doesn't work. Also, you could take the 30 degrees and put the 30 degrees over here. So you can make this 30 degrees and have it go on forever, and either have the 5 go right here or have the 5 go right here is the point. There's different ways to have an angle, a side, and a side, and have the same angle, the same side, the same side. There's ways to make different triangles out of that. If you did it long enough, you'd come up with a few different ways. So is side, side, angle, or backwards, angle, side, side. So SSA or ASS. Is that a reliable way to prove congruence? No, it's not. So on this, you're not going to check SSA or backwards ASS. I know the jokes. ASS, don't bother with the jokes. That is actually one way you can remember that this is no good. This will not prove triangles to be congruent. SSA, if you make it backwards, ASS, don't be one of those, basically. I'm not going to cuss. I don't like to cuss, but you get the idea. So this is no good. Okay, let's try AAS. Angle, angle, side. Will this prove that two triangles are congruent? So let's go, if we're going to do an angle of, say, 30 degrees, and then this side can be whatever length we want to make it, but then the next angle, let's say if it's going to be 60 degrees, a little bit steeper, and then angle, angle, side. We're not doing angle, side, angle. So this side has to be an unknown. It's either the side right here or the side right here we can make. So let's say if this side is 10, and it has to be like that, okay? So this angle has to be 30. This angle has to be 60. So if I do this, well, let's go like this. Okay, so because this has to point that way, and this has to point like that, so it goes like this. Okay, so 30, 60, and 10 is what we're going to have. So we know we have to have 30. We know we have to have 60. And we know that this has to be 10. So I have to go about the same length. Is there a way to make that into a different triangle? Well, let's think about it. If I shorten this over to here, so if I try to put this right here, so because I'm allowed to shorten that side, so let's say if I shorten that side and put the 30 degrees right there, well, what's the problem now? Well, this has to be 10. It's angle, angle, side. There's a same angle, same side. So if on this one, if I do angle, angle, side, well, this has to be shorter than 10 now. It's not going to work. If I make it longer, it's going to point up here, and this can't be longer than 10. So even though all we're saying has to be the same is the angle, another angle, and then the side, it actually is enough to force us into making the same triangle every single time. We make the same triangle twice. So angle, angle, side is a reliable criteria to use. Angle, angle, side. Lastly, angle, angle, angle. I actually think this is the easiest one. Let's go like this. Let's go 90 degrees. And then we'll go, let's go 90, 45, 45. Here's how this is so easy to prove. Let's just do this. Let's just trace around the outside. Look, 90, 45, 45. Is it the exact same triangle? No, it's got the same angles. It's just bigger. Those are called similar triangles, not congruent triangles. Similar triangles both have all the same angles, so they're the same kind of triangle, just one is bigger than the other. Are those congruent? No, they're not. They're similar, but they're not congruent. And so having three angles in common, if you have the same three angles on both of your triangles, is that enough to prove? No, it's not. So on this, you should have everything checked except for the SSA and the AAA. Okay, number 7. Explain why there are a few. I'm sorry, I've loaded this in with typos. Explain why. Explain why a few of the above sets of parts cannot prove a triangle is congruent. Okay, so explain why a few of the above sets of parts cannot prove a triangle is congruent. Go ahead and pause, think about an answer, and then press play, and I'll go over this. Okay, hopefully what you came up with is because cannot prove a triangle is congruent. What you could do is because using those parts, you can make different triangles. Like, for example, you can use angle, angle, angle. You can use three angles in common and make two completely different triangles. Right here, you can use a side followed by the same side, followed by the same angle on two different triangles, and they're different. They're not congruent. So that's why. So why is it that some of those parts cannot prove a triangle to be congruent? Well, because using those parts, you can make different triangles. Okay. You know what I'm going to do? I'm going to split this up. I'm going to end the video here, and this is going to be on top of me just kind of teaching these skills. And then what you have here is actually putting them into practice and trying these. So what I'll do, this will be a little different. I want you to go and do all of these, and then I'll have a video of me going over the answers at the bottom.